Hi, so now I'll be going over the frog dissection. So here I just took two pictures of the frog from the front and bottom. Um, I guess I can start by pointing out the cloaca. That's essentially the universal opening for waste products and reproductive products, sperm and eggs. Frogs primarily breathe through their skin. It's cutaneous respiration, just lets them exchange oxygen through their skin. And they have these giant, well, like proportionally giant hind legs because their main method of locomotion and hunting is through jumping. See, I guess I'll move on so I can get a closer view of these things. So here we have the tympanic membrane. It's kind of like an exposed eardrum, so it goes both ways. How they hear and it's how they release vocalizations. Here we have the eyes, and they're covered by this. They also have a nictitating membrane, kind of like sharks. We have the nostrils here. And again, the nictitating membranes protect the eyes. Okay, so the mouth has most of what's left for the external anatomy. So frogs have two sets of teeth on the upper portion of their mouth. Obviously, since they only have it on one side, it's not really for chewing, it's for holding their prey in place. The this layer of teeth, the one closer to the outside, those are the maxillary teeth. And these two over here, there's only two, I believe, are the vomerine teeth. These holes here, those are the nares. Those are essentially nostrils. They lead from the nostrils into the mouth. I guess this is a good time to talk about the respiration. So they have the cutaneous respiration, which is the main form of respiration. They also have bucopharyngeal respiration, which uses the membranes in the mouth and the pharynx to respirate. Basically, they draw air into the mouth, and then it just transfers oxygen there. And then they actually do have pulmonary respiration, but it's not like what they rely on, so it's not particularly advanced. Essentially, they take in air into their mouth, and then they raise the floor of their mouth and press down with their eyeballs to force air into the glottis, which is basically their pharynx, and the esophagus is above it, this thing over here, or at least the opening to it anyways. And the way they swallow is basically the same as how they do pulmonary respiration. It's just that they close the glottis so that the food, instead, when they press down with their eyeball and press up with the floor of their mouth, it goes into the esophagus instead, and then into the stomach. So besides jumping, the other main adaptation they have for catching prey is this tongue, which oddly enough, it's attached to the frontal portion of the mouth, the more anterior portion. And it's sticky on the posterior portion. So when they land, they can flip it out and curl it back in, and it'll just like act as a little fly trap to capture prey. Now these are the eustachian tubes. They lead to the ear, and they help equalize pressure. Like if you've ever been on a plane or dove to the bottom of some pool of water, pressure builds up in your ear. I think that's it for the mouth. Yeah. Okay, here we have, so my frog was a male. Males have enlarged thumb pads. Lets them grasp onto the female during mating. Okay. This picture is for the coracoid bone. In frogs, it essentially replaces the sternum. It's below the clavicle, so this should be the coracoid here, and then I guess it would be somewhere around here. It's essentially like part of the shoulder, and I guess for frogs it'd be pretty important because they're landing on their front legs all the time. So this is after opening up the musculature. Here's that giant three-lobed liver. Like with other animals, the liver produces bile. That's its main function. Bile helps with digestion. It's an emulsifier, breaks down fats. Speaking of fat, all of these orange things are fat bodies which store fat. My frog had a lot of them. This is only like half of all the fat bodies that I removed. Below the liver is the gallbladder, which holds the bile, and the bile is eventually pumped into the duodenum, which is the opening of the small intestine. And the other thing that's pumped into the duodenum with the bile is the enzymatic secretions from the pancreas. Sure I have a better picture. I think that might be the pancreas. It was kind of hard to tell. But anyways, the pancreas releases more digestive enzymes and produces hormones such as insulin. So move on here. So here's the stomach. Here's better. So here's the stomach. After food enters through the mouth, goes through the esophagus, the stomach holds the food, it can expand, and that's where a lot of the mechanical digestion occurs, some chemical digestion. And then once the food's broken up into small enough pieces, it goes through the duodenum into the small intestine, where most of the absorption occurs over here. And as we know, the small intestine has a lot of villi for the increased surface area inside of it. And I guess since it's over here, this is the large intestine. And yeah, this is the large intestine. And this is where most of after all the nutrients are absorbed in the small intestine, this is where water is basically reabsorbed, and it's packed and stored in the colon until it's excreted from the cloaca. Okay, so pancreas. This is the spleen that helps with the immune system. And the smaller reddish structures that are attached to the kidneys, which I'll show again later, those are the testes, because again, this frog is male, testes produce sperm. Okay. So yeah, so frogs do have pulmonary respiration, but as you can see, these are the lungs, that's the heart. But yeah, like especially looking at the lungs, it's not really what they're specialized in, so they're kind of small. I mean, the heart's larger than them. The heart itself is covered in a pericardium or pericardial sac. It's kind of protects the heart, especially since the heart's just like pumping away against all the other structures. The heart in this frog is three chambered. It has the right and left atrium and one ventricle. Yep. And so it's more efficient than a two-chambered heart, but there's still some mixing going on between deoxygenated and oxygenated blood. Oh, and I guess I should point it out now. So over here about should be the cloaca. It's kind of hard to tell. I mean, it would lead from the large intestine, so it's covered technically, but behind it sort of is the urinary bladder, which, you know, based on the name, obviously just holds urine, the waste product of the urinary system. And I think I had a picture of, yeah, so this is the vessel that's usually attached to the urinary bladder that I cut away. Okay. And then I guess this might be the urinary bladder here. But anyways, here are the kidneys. Those are the powerhouses of the urinary system, I guess. They're the ones that filter out the blood for waste products that can be urinated. And then this is a better view of the testes. This is just leftover bits of the fat bodies. And I think that's it. Yeah. Okay.